Okay, so in this lesson, we're going to be talking about the different types of representations for data, and we're going to focus on a dot plot, we're going to focus on a box plot, and then we're also going to focus on a histogram. So we're going to start off with creating a histogram. So in your packet, you should have what's called tomato plants histogram. And what we're doing is we're looking at a frequency table. So you're going to have to figure out how many times each of these values fits into this range. What you need to understand is that this is not 40 to 50, because then this is 50 to 60. So then you can't have 50 in the same spot. So this is 40 to almost 50. This range is 50 to almost 60, and then it's going to go on from there. So 50 is going to be found in this one, 60, 70, and 80. Okay? So if I look at my data that I'm given for the heights of tomato plants, I'm looking for the range of 40 to almost 50. 40 to almost 50, I have 1. 50 to almost 60, I have 1, 2, 3, 4. And sometimes you'll see me do like tally marks instead. 60 to almost 70, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I were doing tally marks, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you see that, that's what it means. This is 70 to almost 80. So 1, 2, 3, 4, 5, 6, 7, 8, 9 again. And then 80 to almost 90. So 1, 2, 3, 4, 5, 6. And then 90 to almost 100, I just have 1. Okay, so that's how you count and fill out the frequency table. So we're going to use that data to create a histogram. And I'm probably going to make it kind of small so you can see both the top and the bottom slides at the same time. So when you're creating a histogram, it reminds me a lot of a bar graph, but the bars must touch. Okay, so the bars must touch. So if I'm looking at this range of 40 to 50, so 40 to 50, or rather 40 to almost 50, I'm going to put like little marks here so I can see that. So 40 to almost 50, there's only 1. So I'm going to go up to this bar of number of tomato plants. I guess this wasn't height, it was the number of tomato plants. So there's 1. 50 to almost 60, we had 4. So I'm going to go up to the 4. Try to draw it as straight as I possibly can. 60 to almost 70, there were 9. Go up to my 9. Um, 70 to almost 80, there was 9. 80 to almost 90, there are 6. And then 90 to almost 100, there was 1. Okay, so that is how you create a histogram. We will talk more about the benefits and the pros and cons of a histogram versus a different type of data distribution. But right now we're just learning how to, or kind of reminding you how to make them. So again, at any time if you need to pause this video, please do so. So sometimes, and I'm not going to do it, but sometimes you'll see different intervals. That's part of the challenge of making a histogram, is what interval to actually use. This looks like a pretty good one that we created because we can clearly see a rise and you can see some kind of a shape. Sometimes if you end up with the interval being too small, you're going to end up with a lot of jumping around and it's kind of hard to see what's happening. So here's one that I have done previously. Again, I'm not going to spend the time to actually do this on the video, but you can see how it gets rid of like that one cluster it kind of spreads the data out a little bit more. So again, your interval is really important. So make sure that you are making a good choice with your interval. So when we are using the box plots, there's a lot of information with a box plot. This right here is called the 5-number summary. Okay, so it's called the 5-number summary, and that is what you need in order to create a box plot. So we're going to talk about all these different pieces with finding the median, finding the quartile 1. So we're going to break all of this down. So to find the median, it is the middle number of your data. So if I use the same numbers from the tomato plants, I'm just going to pull it down here. So there are 30 numbers. So because there's an even number of numbers, that means that we do not have one number that's specifically in the middle. So what I mean by that is that if we had 5 numbers of data, so if we had 5 numbers in our data, for example, we would have 1, 2, 3, 4, 5. So we clearly have one number that is in the middle. So we'd have 2 over here, 2 over here, and then there is one number in the middle. When we have 30 numbers, it's an even number. So that means if we split that in half, we're going to have 15 numbers here and 15 numbers here. So we do not have that one number that's in the middle. So if you think about this, the way that you find the median is here's your first 15 numbers. This would be number 16. So it's numbers 15 and 16. That would be the 2 numbers in the middle. So if I look at my data, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then this one is 16. So my numbers of 70 and 72 would be the 2 numbers in the middle. So in order to find the median of that, you find the average of the 2 numbers in the middle. So you'd find the average by adding them up, dividing by 2, and it's going to give you 71. So 71 is going to be my median of the data. Okay, so I'm going to scroll down here, and I'm going to put that in my 5-number summary. So 71. So we just found it, we added it to the table, and then what does that mean? That means that 50% or half of the data is 71 or below, and half of the data is 71 or above. So it takes our data and splits it right in half. Next thing we're going to do is we're going to look for our quartile 1. So the quartile 1 is finding half of the lower half. So what that means, I'm going to go back up to here. So remember this was, I'm going to get rid of this. This first line represents my first 15 numbers. Okay, so that's the bottom half of my data. This is going to be the top half of my data. So when I'm finding the median, what I'm going to actually do is find the median of the bottom half. That's going to give me my quartile 1. So here I have 15 numbers, so that's an odd number. So that means I'm going to have 7 numbers on either side, and then I'm going to have 1 number that's in the middle. So I'm looking for actually number 8. So 7 numbers and then the 8th one. So 1, 2, 3, 4, 5, 6, 7, and 8. So this is going to be what's called quartile 1. So we're going to go back down to here. So quartile 1 in this case was 62. It says we added to the table, so let's add it to the table, 62. Then what does the value mean in this situation? So what this does is it takes our data and splits it into quarters, just like a football game. So this means that a quarter of the data is 62 or below, and 3/4 of the data is 62 or above. Okay, moving on. The next question, we are looking for quartile 3. So what we're doing is we're finding the median of half of the top half of our data. So I'm going to go back to this. So here's the top half of our data, and I want the median to that one. So again, we have 7 numbers here, and then we have 7 numbers here, so we're looking for the 8th value. So 1, 2, 3, 4, 5, 6, 7, 8. We're looking for number 78. We're going to put that in our table. And then what that means, because we're in quartile 3, that means 3/4 of our data is below. What was my number? My number was 78. I'm going to reword that. 3/4 of the data is 78 or below. Change that. Is 78 or below. And that means a quarter of the data is 78 or above. So the easiest 2 numbers to finish in our table are the minimum and the maximum. The minimum is just the smallest value, and the maximum is just the largest value. So if I look at my data, I have 47 is the smallest and 90 is the largest. So I'm going to go down here and fill up my table. 47 and 90. So if you have done your 5-number summary correctly, all these numbers should be in order from lowest to highest. Make sure when you are using your data that your data is also from smallest to highest. So when it comes time to actually complete the summary, what I like to do is just put tick marks first. So your box plot should be floating above your number line. So my numbers that I have are 47. So I'm going to do like a 40. 47 is about right here. 62 is about right here. 71 for my median is about right there. 78 is approximately there. And then 90 is over here. Your 3 values of quartile 1, your median, and your quartile 3 all create the box. The rest, it used to be called whiskers. So it used to be called a box and a whisker plot. So this represents your minimum, quartile 1, median, quartile 3, and then we have our maximum. So if we are looking at the strengths of the representations, so why you should choose one versus the other. Now we did not create a dot plot. The dot plot, if we were to create a dot plot of the same data, what you'd be looking at is you'd be creating a number line, much like what we did for the box plot. Let's see if I can find my data here. So you would be saying like we have 45, 50. I'm just going to kind of quickly sketch something in here. I'm not going to complete it though, just so you understand. So we had our data of 47, so then you'd put a dot about 47. We had a 52, so a dot about at 52. If you looked, when we got to 65, we had several of them. So we had 1, 2, 3, 4. So you'd have 4 dots representing the 65. So there's some pros and cons about each of the types of plots. So for example, a dot plot lets you see all of the data and how it is distributed. So think of, when I say how it is distributed, think of the shape of it. And we'll talk more about that in a later lesson. So that's a strength. A histogram summarizes the data into intervals. And then a box plot, I'll put that up here. A box plot displays the 5-number summary graphically. So what are the weaknesses of each of the types of representations? So a dot plot has many columns of dots. And can make it difficult to determine a pattern. I'm going to put in parentheses a shape. So you can see if we would have continued with this one, we would have had one single dot on several of these all the way until we got to 65. Then we finally had more than one piece of data on the 65. So that would not have been a good choice for a dot plot. Another thing that is a weakness is that the box plot and the histogram do not display individual data. So that means you cannot calculate the mean or the median if you're not given the data and are only given the graph. And then finally is, how do you find the typical value for a data set? If you see the word typical, you can calculate the mean or the median. Or you can estimate the mean or median from the graphs. And we will talk in the next lesson that there are, depending on what your graph looks like, you're going to want to choose the mean or specifically the median. So you don't really have a choice if you know what the graph is actually representing. So we'll talk more about the different types of shapes in the next couple lessons.